Hello everyone, my name is Graphics. Now we want to look at another problem in control system where we are analyzing this network here. Now if you look at this also, we have a summer, 3 blocks, which is giving us gain 1, gain 2, and the gain 3, and the gain here, right? So we have one takeoff point altogether, and we have to summer. And this is a negative feedback system. There are many ways you can do this. One of the ways that you can do this is that if you look at this shape here, right? We said that when you have something like this, it will be this G2, one on the line with the summer, right, all over 1 plus the G2 times the H. That's what we have there. So if I should use my reduction method to do this, as block diagram reduction, I'll be having this. Now this is what we have, right? So all this guy you see here amounts to this transfer function here. Now what do you notice? Both of them are in. There's still one more that we are not done. There's a guy here coming up. This we have. Then it is at this point here. So all good. This is what we have here. So all this here is giving us this, and we still have this coming in. Now what do you notice? These two here are in series. So if I should reduce this again, I'm going to be having this. So let's do that and see. It will be G1 times G2 over 1 plus G2 over G2H. So we're having this. Now this is the next thing that we're having. When you multiply these two, you'll be getting this. Alright? Now what you notice, we also have the same shape. Right? We have the same as we have before. So whenever you have this, don't forget there's nothing here, so it shows a unit element that is here. So I'll put my silent 1, right? So let's see. So the keyword there is telling us that if we have a symbol like this, just like we've been having in our previous videos, if you have anything like this, it means that the gain of this gain, right, that is on the same line as the summer, that is G1, G2 all over 1 plus G2H, right? That is this divided by this 1 plus this times this. So it will be divided by 1 plus G1 G2 all over 1 plus G2H times what? This, which is 1. That is just the rule there, right? So if I do that, if you write this back again, that will have G1 G2 all over 1 plus G2H, right? So still divided by, now if you look at this, now we have 1 plus 1 times G1 G2 give me G1 G2 over what? 1 plus G2H. So this is another one here. So if you do the LCM here, right, you are going to be having G1 G2 all over 1 plus G2H divided by, now the LCM of this is 1 plus G2H, and this is like having a silent one under. So 1 in this will give me this times 1 here will give me 1 plus G2H. 1 plus g2h in 1 plus g2h will give me 1 times g1 g2 will give me what? G1 g2, right? Or you can say 1 times g1 g2 will give me g1 g2, and 1 plus g2h times 1 will give you 1 plus g2h times 1. So from here, if I rewrite this again, I'll be having g1 g2 all over 1 plus g2h. If I change this to multiplication, this will change position. So we're having 1 plus g2h all over 1 plus g2h plus g1 g2. So in doing that, you discover that this will equate this, right? And we'll be left with what? G1 g2 all over 1 plus g2h plus g1 g2. So this is my overall transfer function. So if I now redraw this that I have here, if I redraw this I have here now, I'll be having something like this, right? I'll be having something like this. So let's do that. So I'll be having something like this, which will be this. This is the overall transfer function. Let's write it out. What we got here is our final value, which is telling me g1 g2 g1 g2 all over 1 plus g2h plus g1 g2, right? And this is CS output and this is RS input. So we say the overall transfer function is giving us what? The output CS over what? The input RX, which is going to give us g1 g2 all over 1 plus g2h plus what? G1 g2. You can rearrange them anyhow you want to arrange them. It can be 1 plus g1 g2 plus g2h, because addition is what? Associative, right? So this is one way of doing it, right? Now you can choose to prove it if you want to. You can do what? You can choose to what? To prove it if you want to, and you get the same result. Since I'm having a negative feedback, which is coming from CS here, output, and I'm having it this way also, what will I do? I can redraw my diagram to be like this. Now, this is the linear part of it, which is all this we have here. Now there is a feedback, like a report back to the summer, the summing point, and that is what? The output. So it means that at this point here, this will give me, because there's a unit element here, right? A unit gain here, so I can call this to be CS times 1. That will be what? The output here, CX coming in, because the CX, the output is coming in here. Now also the same negative feedback, the same CS is coming into here, right? So I can decide to do this. So we have positive, we have negative, but in this case CS times H will give me CS, HCX, right? So I'll be having here, which will be H, then we have CX, that is the gain times the output coming in here. So this is another way of drawing this, right? So from here you can now say that this is A right? You can now say this is what? This is A. Altogether, this is B, and this is what? C. Or let me use the word P, just to avoid confusion. Let me use P. So if I want to do that, I will now say that let A be equals to Rx, right, minus CS. That is this minus this. That will give me equation 1. Then I can also say that B will give us G1A, that is G1 times A. I can call this equation 2. I can say P is equals to what? B minus HCX, that is B minus HCX. This is summing point, right? I can call it equation 3. I can move forward and say the CS is equals to G2P, that is G2 times P. It's like we are proving, right? Now I'll call this to be equation 4. So from this point here, I'm moving this direction, right? So what I will do here is I'm going to say that substitute P equals to B minus HCX, that is the gain times the output, into equation what? Equation 4. So we move further, we write it Cx is equals to what? G2. So I'm writing my P, I will input this value, and that will give me B minus HCX, right? So if I expand, I'm going to be having CS, that is the output, is equals to G2B. G2 times B will give you G2B, minus G2 times HCS will give you G2HCX, right? So I'm going to term this, I will term this equation what? Equation 5. Now also use substitutes, right? B equals to what? G1A into equation 5. And what is B? B is G1A, so put into what? This equation 5. So we have CS equals to G2, so let me write my B and we put this, we have G1A minus G2HCX. I'll turn this equation what? Equation 6. Now what am I having here? I'm still having a constant which is A, so I'll say substitute A equals to what? RS minus what? CX into equation 6, right? And what is A? A is RS minus CS. I'll put it into what? Equation 6. So if I do that, I'm going to be having CS, right? CS equals to G2, G1. So I'm writing the A, I'm going to put RS minus what? CS. That is the input minus the output, right? I'll close the brackets, minus G2 HCS, right? So if I open the bracket here, I'm going to have the output equals to G2 G1 times the input, and I'm expanding this bracket here, minus G2 G1 CS, right? That is the output, minus G2HCX. Now, since I've done all this, the next thing I will do is I've looked at that there's no representative here anymore. So what I will do is I'm going to factorize. So by factorizing, take all the one that has output to the left hand side. So I'm going to be having CS, the output, minus G2 G1 times the output, right? When it's coming, it will become plus, and when it's coming also become plus G2 H times the output, right? Equals to, we're left with what? G2 G1 RS. Now, what is common throughout? CS is common. I have CS here, I have CS here, I have CS. So if I bring the CS out, if I factorize it out, I'll be having the quotient of CS remaining here is what? 1, plus the quotient of CS remaining here is what? G2 G1, plus the quotient of CS remaining here is what? G2H, right? Equals to what? G2 G1 RX. Now from here, you need to divide by what? By the input. So we have dividing both sides by CS, dividing both sides by what? By CS, right? By RX, dividing both sides by RS. So we are going to be having the output multiplied by 1 plus gain 2, gain 1 plus gain 2 and H, gain H here, all over what? RX, right? Equals to gain 2, gain 1, the input, all over what? The input. So this will equal this. So we'll be left with this 1 plus gain 2 gain 1 plus gain 2H all over the RX equals to what? G2 G1. Now the next thing you do is to divide by this. So if you divide by that, what will be left with will be CX over RX equals to G2 G1 all over 1 plus G2 G1 plus G2H when you divide both sides by this, right? So this is what we're having. This is the overall transfer function. This method you see is the method where you have to prove it, right? So you can compare and contrast the initial one that we did and this. So if you found the video helpful, please don't forget to click on the subscribe button. Thanks for watching.